All right, let's take a look at this problem here. We're taking a secant function. It has a negative in front. Okay? And so when we take our stretching factor, the stretching factor is going to be the absolute value of this number, that multiplier in front of our function. So the absolute value of -7 is 7. So there's our stretching factor. Okay? The period is going to be found, since the secant corresponds to a cosine function, we're going to take the period of a cosine, 2 pi, divide by whatever the multiplier is in front of my x, which is 7 pi. The pi's cancel, and so my period is going to be 2/7. The phase shift happens by taking whatever's inside your function and finding out what value of x gives you a 0 inside. So if I take the 7 pi x, the value, the expression that's inside my function, set it equal to 0 and solve for x. So if I divide both sides by 7 pi, I get x is equal to 0. So there is no phase shift. Okay, and then finally, my relative mins and relative max and my vertical asymptotes, I'm going to need to look at the sketch of my graph to see where those are going to fall. So let's take a look at this graph. I take my vertical shift, which is down 9. So if I plot my midline, is that vertical shift at -9. Okay, and then my amplitude is the absolute value of this stretching factor. Again, I'm talking about the corresponding cosine function that I'm sketching here. So right now what I'm going to do is I'm going to sketch the corresponding cosine function to see where my asymptotes lie. So right now I'm going to sketch this graph right here. So here, since my amplitude is absolute value of -7, so 7, I'm going to go up 7. So up 7 is -2, down 7 is -16. So there's where my highest and lowest values for my cosine function are going to fall. And there is no shift, so my first critical point is going to be at just right along here at the 0. And then my second critical point, or my last critical point here, is going to be at the end of my period. So if my period is 2/7, this graph will complete one full, this cosine function will complete one full period between 0 and 2/7. Okay, so I know that my normal cosine function looks like this, where it has a maximum, a midline, a minimum, midline, maximum. Those are my 5 critical points. When I take a negative, the negative is going to change that to start with a minimum, midline, maximum, midline, minimum. So this is the pattern that I'm going to use for this sketch. So I'm going to start at the minimum. So my minimum here, and I'm going to cut it in half and cut each of those halves in halves. So I go minimum, midline, maximum, midline, minimum. So this right here is what my basic cosine function, my corresponding cosine function, is going to look like. That's the graph of this equation. Okay? So I can find what these actual values are by cutting them in half. If I take half of this distance, 2/7 divided by 2 or times 1/2 is just 1/7, so that's this critical point. And then cut each of these in half, so half of 1/7 is 1/14. So when I'm finding my critical points, so 0, 1/14, 2/14, which is 1/7, 3/14, and then 4/14, which is 2/7. So what that gives me is my critical points at 0, 1/14, 1/7, 3/14, and 4/14 or 2/7. So those are my 5 critical points. They fall here, 0, 1/14, 2/14, 3/14, and back to 4/14. So when I look at these, what I can see here is my relative mins and maxes. So everywhere that this cosine function, in green right here, passes through the midline, I'm going to have a vertical asymptote for my secant function. So I'm going to go ahead and sketch those vertical asymptotes here. Okay, and then my secant function is going to be built off of the sort of the hills and valleys of this cosine function. So everywhere there's a hill of my cosine, I'm going to create sort of a valley for my secant. Everywhere there's a valley down here, I'm going to create a hill. So my secant function looks like this. Again, everywhere there's a minimum on my cosine function, I'm going to have a maximum in my secant. Okay, so in this darker, thicker blue line, that is the actual graph for my function. So what I can see here is my relative minimums for my secant function fall here at the bottom of these U-shapes. So my relative minimums are at this value -2. My relative maximum are going to be at the top of this upside down U-shape. So my relative maximums are going to fall at this level here, -16. So there's where my maximums are. Now again, this is counterintuitive because the number -2 is greater than the number -16, but -2 is my minimum because it's the bottom of my U-shape. -16 is a maximum because it's at the top of my U-shape for the actual secant. Now, if this was asking us for the cosine functions, then my maximum would be the -2 and my minimum would be -16, but those get switched out when we're dealing with the reciprocal function. Okay? And so the final question asks us to identify the vertical asymptotes. So the vertical asymptote that is to the left of the origin. So here's my origin. The first one to the left is this one right here. So I'm looking for the equation of this function, and then the one to the right of the origin, the first one to the right is this graph. So I can see right here that this is 1/14 to the right of the origin. So that is my vertical asymptote here. X equals 1/14. Okay, and so if I move to the left, I'm going to move to the left that same number. So this would be -1/14. So -1/14 would be the equation for this asymptote. Okay, and this would give you the information you're looking for.